Hello Year 10. Today we're going to look at fractional indices. But before we do the new work, let's quickly revise what we learnt last lesson, which was to do with scientific notation and significant figures. So for question 1, we want to turn these numbers into scientific notation and then round to 3 significant figures. So the decimal point needs to go after the first number that's not a 0, so it needs to go between the 3 and the 4. That will make it 3.4176, and then it will be times 10, and we count how many places we've jumped the decimal point. The decimal point would have started at the end of the number, and we've done 1, 2, 3, 4, 5, 6, 7, 8 jumps, so it'll be times 10 to the power of 8. Then, for significant figures, we start counting from the very first number, which is the 3. We want 1, 2, 3 numbers, which means we need to round off from the 7 onwards. 7 rounds up, so that will make the answer 3.42 times 10 to the 8. Let's do it again. For part B, we want to move the decimal point so that it is after the first number that's not a 0, which means between the 1 and the 6. So it'll be 1.607 times 10, and we count how many places we've jumped the decimal point. 1, 2, 3, 4. Because this was a small number, it'll be to the power of -4. And then let's check for our significant figures. So we have 1, 2, 3. The 0 would be the third significant figure. And again, a 7 is going to round that up. So our final answer would be 1.61 times 10 to the -4. Question 2, we need to evaluate a very messy looking expression there. It says using scientific notation to 3 significant figures. Now this is meant to be done on your calculator. So bring up the calculator. We need a cubed root of 7.04 times 10. So you press the times 10 button at the bottom of the calculator there, to the power of 6. Then make sure you push the across button so that you're outside of the square root sign. And then you go divided by 8.3 times 10 to the power of -4. Press equals. Okay, so that is our number. To put that into scientific notation, we need to put the decimal point between the 2 and the 3 at the beginning. So it will be 2.30911. If I stop at the next one, it actually rounds to be a 2, but because it was an 8 in the answer there. Let's count how many places we've had to jump the decimal point. 1, 2, 3, 4, 5 jumps, so times 10 to the power of 5. Now for 3 significant figures, we want the 2, the 3, and the 0. The 9 will round that up, so that it will be 2.31 times 10 to the 5. Okay, new work time, fractional indices. There are 2 laws here in the boxes that we need to learn. So if you have a to the power of 1 over some number, so they've used n to represent the number, whatever that number is the type of root that we have. So if it's a 2 that was on the bottom of that fraction, it would be a square root. If it's a 3, it would be a cubed root. If it was a 4, it would be a fourth root. Okay, and then the a comes underneath, be a fourth root, or in this case, an nth root of a. If you have different numbers on the top and the bottom of the fraction, so you don't have a 1 on the top of that fraction anymore, the n on the bottom is still the type of root that we have, but the m is a power underneath the square root sign. Okay, that could also be written as, you can move the m outside, so that all of that is to the power of m. So there's 2 different forms of that rule there. Let's practice. In example number 1, we want to evaluate 4 to the power of a half. Now, yes, you could put these into your calculator, but we want to practice our new rules here. So a power of a half can be turned into a square root, because a 2 on the bottom there would be a 2 here. But for square roots, a 2 is a normal square root sign, so we just leave the 2 off there. So it's a square root of 4. And the square root of 4 is equal to 2 because 2 times 2 gives 4. Okay, let's do B. A 100 to the power of a half is going to be the square root of 100, which is equal to 10. Question C. The 3 on the bottom of that fraction makes this a cubed root, and we want the cubed root of 8. A cubed root is asking you what times it by itself 3 times to give 8, and the answer is 2, because 2 times 2 times 2 makes 8. Part D. Now this one has the extra little challenge here of having a negative power in there, which we learnt about in a few lessons ago. So before we can turn that into a root of something, we need to get rid of the negative power first. And we do that by putting the indice on the bottom of a fraction, and then the power becomes a positive 1/3. Then I can leave the 1 on the top and change the power of a third into a cubed root of 125. The cubed root of 125 is 5, so the answer is 1/5. Question 2, it says to evaluate on a calculator correct to 4 decimal places. So let's grab the calculator out again, and we want to do 34 to the power of 1/6. And that is it. We want 4 decimal places, so it'd be 1.799. We have an 8 there, but the 9 after it would round that up to be 1.7999. For part B, we want to do 300 to the power of 1/8, which will be, for 4 decimal places again, 2.0400. Question 3, write in surd form. So we don't want to go to decimals, just turn it into surd. So a power of a half is the same as a normal square root of 55. If you could simplify the surd, that would also be a wise thing to do, but there is no perfect squares that go into 55. For part B, the 5 is going to go underneath the square root sign, but the 2 from the bottom is a normal square root. The 3 from the top of that fraction comes underneath with the 5. 5 cubed is 125, and that is a surd that we can simplify. 125 is the same as 25 times 5. The square root of 25 is 5√5. Question 4. Simplify. When we are multiplying things with the same bases, we want to add the powers. So f is the base, 2/5 plus 1/5 makes 3/5. Part B, when we have powers inside and outside of brackets, we multiply them. So x is the base, 3 times 1/6 is either 3/6, but that simplifies to a half. And then y, we would have 4 times 1/6, which is 4/6, or 2/3. Part C, multiplying the powers together. We're going to have a, and then we have 2/3 times 1/2, which is 1/3. You can always use your calculator to times those fractions together if you need to. And then b, we have 3/4 times 1/2, which makes 3/8. Question 5, write in index form. So they're in square root form. We want to turn it back into a fractional power. So a normal square root sign is the same as a power of a half. So 15 to the power of a half. B is also a normal square root sign, so that will be 7 to the power of a half. Okay, question C, 3x to the 7. We just have to put that in brackets and go 3x to the 7, and all of that is to the power of a half. Potentially, you could expand that out to be 3 to the power of a half and x to the power of 7/2. So both of those are the same thing. They are both in index form. Question D, the 5 is sitting out the front. The a is the base, it is a cubed root, so it'll be a 3 on the bottom of the fraction, and there's a power of 4 on the a, so the 4 goes to the top. So it's 5a to the power of 4 over 3. Question E, we have a 5 out the front, and then we have another 5 that is to a power of a half, because a square root is the same as a power of a half. Now those 5s both have the same base, so we have 5 to the power of 1 times 5 to the power of a half, which means you keep the base and you add the powers. 1 plus a half is 1.5, but we prefer to write that as a improper fraction, which is 3 over 2. Okay, time for you to do exercise 3D.